Okay, so in this video we are going to be looking at rules for filling of electrons into orbitals. The last time we talked about quantum numbers, but in this case we are going to see the rules that guides filling electrons into orbitals. Very important. Now there are three particular rules. The first one is called the Aufbau Principle. Okay, the second one is called Pauli's Exclusion Principle. Okay, then the third one is called Hund's rule. Hund's rule. Okay, so these are the principles that guide filling of electrons into orbital. The Aufbau principle, the Pauli's exclusive principle, and the Hund's rule. Now, when we talk about the Aufbau principle, what is Aufbau principle? Aufbau principle simply states that whenever you are filling electrons into orbitals, okay, you fill electrons of lower energy first before filling electrons of higher energy. You fill electrons of lower energy first before filling of electrons of higher energy. Now, according to Aufbau, he gave us a way to know the energy or electron energy that is higher than the other. Let's say we have 1s, 2s, 3s, 4s, then 5s. Here we have 2p, 3p, 4p, 5p. And here we have 3d, 4d, 5d. Now you should note 2. Principal quantum number 2 does not have d orbital. So you can see 1 does not have p orbital, 2 does not have d orbital. So this is how you arrange it. Now according to Aufbau, this is the lowest in energy, 1s. After that you have the 2s here. After 2s you have the 2p and 3s here. Okay, we have 2p, sorry. Then we have 3s. Then after that we have 3p and 4s. Then for our level we are going to stop at 3d because you are not to go beyond that. So this is the order. Now according to Aufbau principle, if I want to write the configuration of, let's say, sodium is 11. This is going to be 1s2 because 2 for s orbital, 2s2, another 2 for s orbital, 2p6, you see, 6, then 3s 1. That means 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 1 is 11. You see that? Now this is correct. Now, but if I want to violate this principle now, which is the kind of questions you should expect in the exams, I can have something like this: 1s2, 2s1, 2p6, 3s2. If you notice, there is a problem here. You must, this is the problem here, 2s1. This is a violation to Aufbau principle. To Aufbau principle. Now it is a violation because it is disobeying Aufbau principle. According to Aufbau principle, before you move to the next orbital, you must fill the lower orbital first before you move up to the next orbital. I believe that makes sense. So that is it for Aufbau principle. Now the next one is what we call Pauli's exclusive principle. Pauli's exclusive principle. Okay, now according to Pauli's exclusive principle, it says that no two electrons have the same value of the 4 quantum numbers. No two electrons have the same value of the 4 quantum numbers. Okay, maybe I should write that down. No two electrons have the same value of the 4 quantum numbers. Now what that means is that if, you know, in my last video I taught you about 4 quantum numbers. We have the principal, we have the azimuthal, we have the magnetic, and we have the spin. So 2 electrons can be in the same shell but not be in the same subshell. They can be in the same subshell but not be in the same orbital. They can be in the same orbital but not have the same spin. Okay, so 2 electrons can never have the same spin. Now this is a violation. This is a violation to this principle. If, let's say, I have carbon I want to fill carbon. By right, it's supposed to be 1s2, 2s2, 2p6. That's the configuration for carbon. Okay, so s2, 2s2, 2p6. Now, this is taking 2 electrons. This is taking 2 electrons. And this is, oh, sorry, it should be 1s2, 2s2, 2p2. That's a mistake. To make it up 6. So this should be 2p2. So 2 plus 2, 4, 4 plus 2, 6. You see? So p orbital, p has 3 orbitals. And if I want to fill it, I should fill it like this, 1 and 2. So this is correct. But if I want to violate it, sorry, this is not a violation. If I want to violate it, I'm going to have something like this. 1s2, 2s2, 2p2. You're going to have like this. Like this. Now, you notice that there is a problem with this one here. Anytime you see an orbital where the 2 electrons inside that orbital have the same spin, that is a violation. You are violating Pauli's exclusive principle. Okay? It's a violation to Pauli's exclusive principle. Do not forget that. Okay? So that is the second rule. That means if you are writing, if 2 electrons are to be in the same orbital like this, one of them must be pointing upwards and while the other one must be pointing downwards. That's the correct way. That is according to Pauli's exclusive principle. Okay? Now the other one is called the Hund's rule. Now according to Hund's rule says that in filling of degenerate orbitals, we call it degenerate. In filling of degenerate orbitals, okay, you must fill it completely first. You must fill it. You must fill it by half first, then before you now complete it. The question you may be asking is, what are degenerate orbitals? Degenerate orbitals are orbitals of the same energy, like you have p orbitals. These 1, 2, 3 are degenerates. When you have d orbitals, these 1, 2, 3, 4, 5 are degenerate. 1, 2, 3, 4, 5, they are degenerate. So according to Hund's rule, if I want to fill this orbital, let's say I have 5 electrons to fill here. I will fill it singly first. 1, 2, 3. Then before I come and continue, 4 and 5. This is how Hund's rule. If I want to violate Hund's rule, I'm going to do something like this. Watch. To fill in 5 orbital, I will say 1, 2, 3, 4, which is wrong. You don't do this. This cannot be empty. When you can fill it half filled, the correct way, this is a violation. The correct way to fill this with 4 electrons should be 1, 2, 3. Then you now come here and say 4. Are you seeing that? This is the correct way. So that is it for Hund's rule. Whenever you are filling degenerate orbitals, you must fill it half filled first, then you can now complete it fully filled. Let's say I want to write the configuration for oxygen. Very good. Oxygen is O. I think that's the 8th element in the periodic table. Is 1s2, 2s2, 2p4. Now, this is how I will fill the orbitals. 1s2, 1s2, 2s2, 2s2. You see? P is 3 orbitals, so like this. P4 means I'm going to fill 1, 2, 3, before I now come here to say 4. This is correct. Are you seeing that? Not the other way around. You don't fill one orbital before you enter the other orbital. No. Whenever you meet a degenerate, you fill it half filled before you now compare them up. So this is all for this particular rule. Thank you very much. See you in our next video.